Working Cows Podcast, episode 355. This episode is brought to you by Understanding Ag.
Welcome to the podcast that gives producers a platform to discuss and share paradigm-challenging practices. Practices that have increased the effectiveness of their operation and the joy that their families have received from this lifestyle.
Howdy everybody, this is Clay Connery, host of the Working Cows Podcast, recorded exclusively in the Understanding Ag studios, and this episode is brought to you by Understanding Ag.
You've probably noticed that we frequently feature Understanding Ag's experts on our show. Well, there's a good reason for that. Understanding Ag is the world's premier regenerative and adaptive grazing consulting company, which was created for farmers and ranchers by farmers and ranchers. People who have been there, done that on their own regenerative farms. Understanding Ag's consultants aren't in the business to sell you costly inputs. Their sole mission is to help you understand, then grow your profits by applying regenerative principles and practices so you can grow healthier soil, food, farms, and futures, all while reducing input costs. Discover more at understandingag.com. You'll be glad you did. That's www.understandingag.com.
Very excited to be joined today by Brian Dougherty. Brian is an educator with Understanding Ag, part of the team over there, and he's been writing a series of articles that are up on the Understanding Ag blog. They are ongoing, so there are some articles yet to be released, but we're going to talk to him today about the idea of nutrient management. How do we keep nutrients where we want them? How do we get them where we want them? How do we reduce our need to use synthetic forms of nutrient application and some of those things? So very excited for this conversation today. Brian, thanks for joining me today on the Working Cows Podcast.
I appreciate you having me here. Looking forward to the conversation.
Yeah, very good. Really have appreciated some of the blog posts you've written recently on the Understanding Ag website. That'll be linked in the show notes page for today, workingcows.net/355. Workingcows.net/355 is the show notes page for today, and there'll be links to some recent blog posts that you've written. One of them about one series about the carbon cycle, and then also kind of touching on nutrient management issues as well. And that's kind of what we're going to talk about today, is how do we manage these different nutrients. And so when we are talking about nutrient management, what are some of the major nutrients we're referring to?
Yeah, so when I'm talking about nutrient management with growers, primarily we're starting that discussion with nitrogen, phosphorus, potassium. You know, the old school NPK that everybody learned about. You know, if you've ever taken a soils class, that's mostly what people focus on. So that's kind of where we start. Oftentimes, that's your low-hanging fruit where there's potential to really improve the management of those particular nutrients. Now, whether that's changing the timing or how much we apply or how we apply it, you know, those are all the discussions that we get into, and that all comes into their context, you know, for how they're managing their farm. And then from there, we can talk about micronutrients, you know, are there any excesses? Are there deficiencies? Are there things we can do there to help improve their, you know, their overall nutrient management? So that's kind of the fertility discussion side of it. But then there's also what we really focus on is the soil health principles and ecosystem process, and actually getting their nutrient cycle to work in the field, so they don't have to buy as much stuff to begin with. So that's generally what we're talking about when we talk about nutrient management in a cropping context.
There is the fertility side of it. And then there's, I would say maybe that's one way of looking at it. And then the other way of looking at it is the cycle. This is a cycle that we're managing, and that we can cycle some of these nutrients ourselves. Is that a helpful way of phrasing that?
Exactly. So the point I try to drive home with producers is almost every nutrient at some time or another is going to cycle through a microbe before it ends up in the plant. So, you know, when I started learning about soil, 30 plus years ago, when I first went to school for this stuff, we just talked about, it was kind of a recipe book. You looked up a number in a chart You're growing this many bushels, you put on this amount of fertilizer, and the soil was just kind of like a black box. We just kind of ignored what was happening biologically in the soil, but actually almost all of those nutrients, 80 plus, 90% of those nutrients, even the stuff that we apply as fertilizer, is going to cycle through a microbe before it's actually taken up by the plant. So we focus very heavily on how do we optimize the biological side of that nutrient management and actually that nutrient cycle. So we get that soil to produce for us, because we can show through different ways of soil testing that there are often hundreds to thousands of pounds of nutrients out there in the soil that just are not necessarily available to the plant, but they could be if you can get your biology to work. And so we focus on how do we unlock those nutrients, how do we use those nutrients, get them to cycle better so that we can, rely less on bringing external inputs into the farm.
Is it a lack of underground biological diversity that means that those nutrients are not available? Is that typically the issue, that there are not the right kinds of microorganisms, or maybe not the right levels of microorganisms to take advantage of those underground nutrients that are there but not available to the plant?
Exactly. So we run what's called a PLFA test. It's a phospholipid fatty acid, and that's a really good way to just get a general assessment of what's out there biologically. So we're looking at the levels of bacteria in the soil, but much more importantly than bacteria are our mycorrhizal fungi. So those are the good guys that are going to tap into our plant roots, and they're going to feed nutrients and water to that plant in exchange for carbon. So when we talk about getting nutrients to cycle, they're just I like to think of them as basically a keystone species in the soil. So we can use a PLFA test, for example, to look at the levels, or if they even have any. Sometimes these tests come back and there's just no mycorrhizal fungi. So I know right off the bat that system's completely broken. Those nutrients are not going to cycle biologically, because the mycorrhizal fungi are just such an important player in that whole underground ecosystem that's happening in the soil. Then on the bacteria side, we don't need just bacteria. We also need that whole soil food web. We need the protozoa. We need the nematodes. We need the beetles and things to shred the residue. We need all the players there to get those nutrients to cycle, because, protozoa, for example, they will actually eat your bacteria and poop out the extra nutrients that they don't need. And that's all part of the nutrient cycle that we're trying to get to work in the soil. And so we focus on how do we get the life back in the soil? How do we get that soil food web working, get that cycle working, so that we can, get our plants to a situation where they can not only access those nutrients, but they're also going to be much healthier and less reliant on things like pesticides and fungicides that we have to use, because oftentimes our plants are just sick. They're not healthy because they're not connecting with the soil microbiome. And so then we have to step in with another fix.
Right, and this is why Nicole Masters talks about our soils being constipated, right? There aren't those protozoa, the nematodes there to consume certain nutrients or consume even other living organisms and then poop out the nutrients that we need to be available to the plant. This is kind of along the lines of what you're talking about, right?
Yeah, exactly. So yeah, when I talk about sick soil, we usually say it's either running a fever, the soil's bare, it's way too hot, you're cooking your microbes, or it's constipated, like you said, the nutrients aren't cycling, or it's got diarrhea, which I'm from Iowa here, so nitrate leaching is a huge issue here, as well as many other Midwestern states. So when we say the soil's got diarrhea, we're talking about it's basically losing nitrate because there's just no living root there to capture that nitrogen and recycle it in the system.
Yeah, you talk about the nitrate leaching. What are some of the ways that actually takes place, or how does that happen? Is it generally happening outside of the growing season, or is it something that's taking place even during the growing season, even during when corn is photosynthesizing, when soybeans are photosynthesizing? Are they still losing those nutrients then, or is it more in the off season?
Yeah, it does take place throughout the growing season. So usually we'll see The majority of losses, if you measure it on a mass basis, are usually in the off season when we don't have a living root. But that doesn't mean that it can't happen in the middle of the summer if you get a big rainfall event. So I'm primarily talking about like tile drain systems here, because that's where it's just easy to measure. So we know what's happening in those systems. That doesn't mean that if you don't have drainage tile, you're not still losing nitrate. We know that's happening because we've got high nitrate drinking water wells all over the Midwest that basically prove that we've been losing nitrate for decades. So yeah, it can happen throughout the season, but it's more of an issue in the off season when we don't have a living root in the soil. And the thing that was probably driving it, or one of the factors that's driving some of our in-season losses, is kind of the way we manage the nitrogen. So we tend to put on large doses, at planting or maybe even the fall before, and that's a big concern. So the timing of it, the amount that we're applying at one time, it's often just well in excess of what that soil can process. So what we would like to see happen is a lot of that nitrate actually converted back to organic nitrogen. So it's in a form that's more stable and it doesn't leach, it doesn't volatilize. Again, if your biology is not working and you put on a big dose of, most of our fertilizer are going to convert to ammonium or nitrate very quickly if they're not already in that form. And so then we've got a large pool of nitrate in the soil. And the challenge with nitrate is it's water soluble. It's very soluble. So wherever the water goes, that's where your nitrate's going to go. So if you don't have either a microbe or a plant root or something there to take that nitrate up very quickly, it's susceptible to loss. So in a biological system, what we're trying to do is rely more on organic nitrogen. So that nitrate becomes more of a just kind of an on-demand type system. The soil's always producing it, and that's okay as long as you've got something there to use it right away. So that's where we're trying to get with the nitrogen management.
I'm going to pretend that other people, I'm not going to say everybody, but other people listening to the Working Cows that's easy for me to say. I'm going to pretend that other people listening to the Working Cows podcast are as naive or maybe ignorant as I am about row crop agriculture, and ask some really dumb questions probably right now. But first of all, drain tile is something that's installed under the soil surface for the purpose of draining wet spots within different row crop fields. Is that anywhere in the ballpark of accurate?
Exactly, yeah. So if we think back even 150 years ago when Iowa was first settled, a lot of it was actually essentially swamp or wetland. So it really wasn't farmable. So there's a good portion of what we call the prairie pothole region in the wetter regions, Iowa, Minnesota, where they actually installed, and where the name came from, tile, it was actually clay tile originally, and they hand dug these things and installed these tile under the surface, and they just had little slots in them. And so if you had the soil is completely saturated, any extra water would flow into these tiles. Well, in modern times, now it's all plastic. So it's just perforated plastic tubing, usually 3 to 6 inches in diameter, depending on, what you're trying to drain. It's
just like the drain tile in the foundation around your house.
Exactly. It's the exact same thing. So if you're familiar with, eave spouts and things like that, you're draining water away from your house, same material. It's just got little slots cut in it so the water can soak into that tile. And so we're basically just getting rid of the excess water out of the field. So that's what drain tile is. And there are some areas, like I said, where it would be very difficult to farm without that tile, but we're also seeing more and more areas where tiles being installed where you really shouldn't need it. The issue there is more of what we call a broken water cycle. So their water, their soil isn't well aggregated, which I'm sure you've talked about many times on the podcast. So the water that they do get to infiltrate, they don't have good infiltration and they don't have good aggregation. So the water holding capacity isn't what it should be. The whole system just doesn't function right. And so the drain tile ends up being sort of a Band-Aid in that situation. So they're basically using that to treat a symptom, whereas the underlying problem is the fact that they don't have good aggregation and their water cycle is not working.
I think part of the problem that we face when we talk about nutrient management is the fact that what conventional agriculture, if I can call it that, is doing is effective, or at least they can get a predictable outcome from it, in the form of, here's what we've got, here's the NP and K, take that, spread it, apply it, and you're going to yield something in the realm of a respectable amount of bushels per acre. And so we've got this linear view of input equals output, and then those nutrients are exported. But it works, and so I think that's part of the problem, is that people are not aware that their system is broken because those things are working. Is that does that match your boots on the ground experience?
Yeah, that's a really good way to think about it. So, I talk about fertility, the way we manage it conventionally on most farms. It's essentially a linear system. We mine it out of the ground somewhere, we haul it to the farm, we apply it to the field. The grain or the forage gets hauled off. Those nutrients don't come back. That's the challenge we need to deal with in the long run. And that's one of the things that we work on a lot with integrating livestock. It really helps tighten up that nutrient cycle, so you don't have as many nutrients leaving the farm. But yeah, it's essentially a linear system that we're dealing with right now. And you're right, it works. I mean, it's worked pretty well previously. The challenge that more and more people are running into is it's just awfully dang expensive to farm that way. And we have more and more clients come to us every year saying, look, this system just isn't working for me anymore. They've got weed control issues. They've got fertility issues. What they were doing in the past that always worked, just isn't working so good anymore. And it's getting too expensive to do it that way. And so they're looking for a different alternative.
Yeah. I mean, it's financially expensive because a corruptocrat and a tyrant get into a fight where most of our nutrients are manufactured, and then we have to, either pay more for them or whatever. That's expensive. But then it's also, there's externalized costs too, in the form of health, issues that people are dealing with from a health standpoint that are probably, and maybe way more than just probably, connected to the way we've been handling these nutrients and the things that we've been doing to combat the issues that arise from mismanaged nutrients. Like weeds, quote unquote weeds, are generally a sign that the soil is trying to heal itself. They're nature's cover crop. They are trying to bring nutrients to the soil surface so that the plants can be healthy. I mean, I'm not speaking for Understanding Ag or Brian Dougherty right now, but I think those are all things that I think you agree with most of those points anyways, and you can speak to them more intelligently if you want to. But I think those are some of the externalized costs that we go out and we have to spray all these other chemicals to deal with the symptoms of a sick system.
Absolutely. Yeah, we spend billions and billions of dollars every year just treating symptoms, and we're not addressing the underlying cause of most of these problems, which is just dysfunctional soil. If that soil worked the way it should, if we could get our water to infiltrate, if we could get our nutrients to cycle, if the biology was working, that would just solve so many problems in agriculture. We could deal with our nitrate leaching issue. We could grow healthier food, and you touched on that. There's absolutely a connection between soil and plant and animal and human health. That's becoming more and more clear through the science every year. We know that healthy plants produce more phytochemicals. We know they're good for us. And we know those very same chemicals are essentially bioweapons. That's how plants defend themselves from disease and insect attack. So we're just creating this whole cascade of problems, and I'm not trying to pick on conventional management. I get it. I was a conventional farmer. That's how I did it. That's how I was taught to do it. That's how my dad did it. That's just the way things were. But we're learning more and more every year about the soil microbiome and how all of these things are connected. And we're starting to realize, wait a minute, we need to kind of rethink how we're doing it here. We have to work with the biology. We can't just keep doing these practices that kill it off and then try to substitute for the function of that biology by just adding fertility or adding pesticides or whatever. We're just creating more and more problems.
And I don't think what we're saying is that people can't grow corn or soybeans anymore. I think that there is a way to do that. I think that you can grow corn and soybeans, and then you can follow it with a diverse cover crop mix, and you can graze that cover crop mix off. And, so we've talked a little bit about the linear system. Let's define, and we've talked about the problems with the broken cycle. Let's define a healthy cycle, and maybe walk me through it in Iowa. What's a healthy cycle look like? What does somebody who is managing nutrients well, what are they doing throughout the seasons of the year? Include in that, a corn crop in that nutrient cycle if you can.
Sure. Yeah. So I'll just use a corn soybean system as an example, because that's what a majority of the people in the Midwest here are doing. That's who I work with primarily. So the first thing we're going to focus on, if I just come onto a farm and they just don't know anything about soil health, and they want to know, where do I start? Well, we have to start with a living root. We've got to keep that ground covered in the off season. That's low-hanging fruit. So we start thinking about what are some of the strategies we can implement to get some cover crops into that system. So maybe using a shorter season, corn hybrid or soybean variety. So it gives us a little bit more time in the fall so that we can get out there and get a cover crop established, because that living root is just so important for soil function and getting everything to work. So other things we can look at are just different interseeding strategies, different times of the year where we might be able to get a cover crop out there. So that's where we start. Then we'll look at just other disturbances. If they're not using no-till or, very minimum disturbance on the tillage side, we're going to encourage that. May need to do some tweaks with equipment, so we can get to more of a minimum or no-till type system. And also your chemical disturbances, fertilizers, herbicides, pesticides, they're all disturbances as well. So over time, we're going to look for ways to, not just go cold turkey and pull those things out, but how can we reduce those over time? So get a living root in. Then we're going to start looking at diversity. Essentially, we're just walking down through the 6 soil health principles here. We start with the context, and we start asking, okay, for this particular farmer, how can we minimize disturbance? How can we get more diversity out there? How can we keep a living root? So a great way to approach diversity in that kind of a system is to take a few acres. You don't have to do this large scale. Take a few fields and switch to a small grain. Grow something other than corn and soybeans. Get a small grain in the rotation, or maybe let your cereal rye go. If you put that in the fall, maybe take it to harvest for grain. Now you've got your own cereal rye cover crop seed. You don't have to buy it. So we're going to look for opportunities like that. Then if we get that crop out in, say, early August, now we've got this huge window where we can come in there with a nice, diverse, warm season cover crop mix. We can pump all kinds of carbon into the soil. We can fix nitrogen. So we look at that point, we're asking, what are the resource concerns? Are they trying to reduce erosion? Are they trying to fix nitrogen for the following crop? Do they want to graze it? So that we'll ask a whole series of questions and design that cover crop mix based around those resource concerns. And so then we can really start getting that system working, because that disrupts that corn soybean. It's not even it's a rotation. It's an alternating sequence. It's a way I've heard people describe it.
I have a friend who said, I probably won't get invited to speak again at this place, but I went to this group and I said, corn and soybeans isn't a rotation, it's a mindset.
Exactly. So yeah, we get some more diversity out there, and that will really jumpstart the soil biology, get the mycorrhizal fungi coming back, all these other things we've been talking about. And from there, it's just tweaking around the margins. If we just hit the principles and figure out how to make it work in their context, and you'll get that soil working. And then I never want to put a number on it, because people always want to know, well, how long is this going to take? But just very generally within 3 to 5 years, you should see some pretty dramatic changes in that soil, just keeping it covered, keeping living root. You'll start seeing your aggregation come back. You'll fix your water cycle. Then we can start looking at inputs and, doing some like zero rate fertility check strips is a great practice. We need to know, what is that soil capable of producing without us having to add it. And then only when you have that information do you really know how much fertilizer do you actually need to apply. We need to know what can that soil do on its own, so we can start looking at things like that.
Let's take a quick break and hear a word from our sponsor today, Understanding Ag.
We've been fortunate to feature some of the world's leading regenerative ag and adaptive grazing experts on our show. And many of those experts are farmer-rancher instructors for the nonprofit Soil Health Academy. This year, you'll have several opportunities to experience and profit from attending one of their remarkable on-farm schools and workshops. Whether you're interested in learning more about diversifying corn and soybean rotations to increase profitability, merging multi-species in marketing, grazing on high plains and in northern environments, regenerative farming and ranching, or enhancing profit and production in your beef or dairy operation, the Soil Health Academy has a school for you. One of the best investments you can make is in yourself, so visit www.soilhealthacademy.org to learn more and register. Financial assistance and scholarships are available.
And how much, when things are optimized after 3 to 5 years or 10 years, when things are optimized and functioning well, and I know this is going to be an it depends answer, but in Iowa, for example, what are some of what kind of fertility is being added in some of those systems? Does it get down to pretty low amounts over time?
It can, yeah. So I know a number of producers that have essentially completely eliminated their phosphorus and potassium applications. And again, like you said, it depends. So what's your inherent soil fertility? We've got lots of farms. Maybe they've been putting swine manure on for decades, and they've got just gobs of nutrients out there, and they don't need to apply anything. What we really focus on a lot, especially in these corn bean systems, is nitrogen. So we like to look at nitrogen use efficiency. So, just, again, looking up a number in a recipe book, you'll get somewhere around, you need a pound of nitrogen per bushel of corn. So if you're going to grow 200 bushel of corn, you put on 200 pounds of nitrogen. We can easily cut that number 30 to 50%. It takes a while to get there. You're not going to do it overnight. But I know, again, a number of producers that are down in the 0.4 to 0.6 pounds per bushel range on nitrogen. They're not giving up any yield. That's the other thing that's always a huge concern. Okay, this all sounds great, but, I don't want to give up any yield. So it's kind of how you want to approach it. Can we do this and maintain yield? Absolutely. Or maybe you can give up a little yield, but figure out how to do this a whole lot lower cost and be further ahead in the end. So either approach can work.
Yeah, and that comes to the issue of profitability, right? If you can get even just a little less yield with less inputs, or no inputs, whatever, then your profitability becomes the issue. And, like we always talk about, you don't get to wear a big belt buckle to the coffee shop, but profitability is kind of fun.
Yeah, we like our yield contests,
Right.
We really need to ban yield contests and have profitability contests instead. That would change agriculture right there.
For sure. Well, and Adam Grady made a great point when I talked to him about that. He said, why doesn't the county average reflect the yield contest winner? It's not every acre. It's an acre in the middle of the field that just happened to be right that year, and so I think those are things that don't get spoken of either at the yield contest award ceremony.
Yeah, I don't mean to knock yield contests. They can be useful for, tweaking management, figuring out what works and what doesn't. But yeah, we just focus way too much on yield, and because that's just been ingrained in how we've been taught to farm, and we got to get out of that mindset and think about profitability and what's, better for the environment in the long run rather than just focusing on yield.
Right. And when you talk about doing a zero rate check strip, how far away does that have to be to get a real good read on these things? Because I understand that some of this nutrient transfer is happening underground on a pretty broad scale. So I don't know how far away would something like that have to be to give you a real good check.
Yeah, it's a great question. So as far as being spread out, they don't really need to be far away. Most of our equipment is big enough. A lot of people are doing this stuff in, 30 to 60 foot wide passes. So really what we're just trying to get people to do is, if they just even just very simple split a field in half and do a treatment, half of it on one, half on the other. That's, if you really want to get good quality data, you probably want some replicated check strips. That's kind of the gold standard. Like, say I'm going to do a rate trial. I'll have a full rate, 3/4 rate, half rate, quarter, however many you want to do. And you'll do that in strips, and then you'll repeat that like 3 times. But realistically, that does get to be a lot of work. A lot of farmers aren't going to mess with that. So if we can at least just get them to do it once and just have some side-by-side comparisons out there in the fields, it's something big enough that you can pick it up with the yield monitor, or you can flag it out and go out there with a weigh wagon or whatever, so you can get some accurate yield data on it to see what did that treatment actually do.
As I said, your first series was the Carbon Chronicles, and then you had a second series, From Symptoms to Solutions, addressing the underlying causes of water quality degradation. And there was one paragraph second paragraph in there, where you talked about the fact that we are applying engineering fixes to a biological problem. And I thought that was a really helpful way of thinking about that. And so could you give me some examples of what you're talking about as far as engineering problems applied to biological problems, or engineering fixes applied to biological problems?
Sure. So I have to confess here, I'm a recovering engineer. So I actually worked as a field engineer for Iowa State for several years and went through the master's program there. And I'm not knocking it at all. Fantastic people. I loved everybody I worked with, but there's just kind of this mindset that, well, we don't really want to upset the system. We're going to keep doing what we're going to do. So let's just figure out, okay, how can we make it a little bit better? So on the engineering side, when it comes to water quality, there's a lot of different practices. So, constructed wetlands, that's actually a pretty good practice. They're very expensive to do, but at least you get some wildlife habitat. There's other benefits of having a wetland. But then there's other things like there's one called saturated buffer. So I talked about tile drainage earlier. So this is basically, it's in just a regular grass buffer strip, say along a stream, but you actually intersect your tiles before they get into the stream, and you run it parallel, and you basically just kind of get the water to flow through that buffer strip to remove some of the nitrate, trying to get plant uptake. So it's somewhat of a biological system. We're basically engineering the tile drainage system in a way to try to remove the nitrate. So that's one. Another one is called a wood chip bioreactor. So essentially you take your tile line and you cut it off before it goes into the stream, and you just run it into a big pit full of wood chips that are buried under the soil, and that causes that nitrate to denitrify, and it's given off as nitrogen gas, and then the water going into the stream is cleaner. So they work, absolutely, but they are expensive, and I guess my point with that is we can fix that problem in the field. That's primarily management. And if we can get to more of a biological nutrient cycle, we won't have that nitrate leaching to deal with in the first place, and we won't have to spend this money on these engineering fixes. They're basically just treating the symptom before it ends up in the river. And realistically, we're never going to be able to scale those up to the point where we can deal with the problem at scale. We've got, I think there's like 10 states that have nutrient reduction strategies now in the Midwest, and I know Iowa's generally the biggest contributor to the issues with the hypoxia zone in the Gulf. When you measure, how many actual pounds of nitrogen and phosphorus we lose every year, we're never going to fix that with engineering. We have to do it in the field with a biological system.
And the biological system is what we were talking about to start out, getting those things all working in sync and optimizing those relationships is what you're talking about there.
Exactly. Yeah. And I'm not saying this is easy, but it is doable. So if you look at a prairie system, for example, you could stick a drainage tile in it and measure that water coming out, and you'd have essentially no nitrate. That system has evolved over time to use that nitrogen very efficiently. So we can somewhat mimic that in a crop system. Again, it's more difficult, but just implementing the principles will get you a long way there. We know just, basic research, just putting in a cereal rye cover crop, you can reduce nitrate leaching by 30 to 40% right there, just with that extra ground cover. And we can do a lot better than that with nitrogen management, looking at timing. So with standard research on that, we have what's called the 4R practices, the right rate, the right time, the right place, that sort of thing. But the research on that says they don't actually do much for water quality. But the point I make in the blog, and there's 3 more parts of that blog that have not come out yet, so I encourage people to keep following that. But the point I make in the blog is, we think about, okay, what's the right source of fertilizer? Well, the right source of fertilizer isn't fertilizer at all. It's soil microbes. And that's the part that we're missing. We've got to get the microbes to supply our nutrients for us in a biological system. Then we won't have anywhere near the amount of nitrate leaching that we have, because that just doesn't occur as much in those type of systems. Iowa State even did a study several years back where they actually fertilized some prairie, and it still didn't. Essentially, nitrate leaching was basically zero, just because you get that huge root mass there. So we just got to think about how can we get our crop system to mimic that a little bit more.
Yeah, I recently facilitated a panel where Jay Fuhrer and Cooper Hibbard were both panelists, and I asked, and it was there was 2 range guys and 2 row crop guys on the panel, and I asked them all these questions about, the 6 principles of soil health, and Jay Fuhrer said, well, we learned the 6 principles of soil health from the prairie. And then Cooper Hibbard said, yeah, you did learn the 6 principles of soil health from the prairie, but you also distilled the 6 principles of soil health so that the prairie guys could understand how to make the prairie better or regenerate the prairie. And I thought that was a helpful kind of way of looking at both sides of that coin, that, when I go out onto my prairie and I see bare ground, I say that's the problem. I need to fix that problem, among others, but that's one of the problems. We have the animal, we've got the livestock integration. We've got some diversity. We would like to have more. We've got some of these things going for us, but the bare ground is obviously what needs to happen there. And so it needs to be covered up, needs to be armor on the soil. So yeah, I think the prairie is the thing that's teaching us, but the prairie guys aren't exempt from improving their resource base either, right?
Yeah, it's a great way to think about it. And so one of the pieces that we're, oftentimes missing here in the upper Midwest, going back to the prairie, is that livestock integration piece of it. And that's where we need to learn from the grazers out there, how to make that work better. So we've, over the decades, for a lot of, oftentimes good reasons at the time, we've taken all of our livestock and we put them in confinement buildings, and we haul all the feed to them. We haul all the manure back out again. And, there's very, very much some challenges with that system. If we're trying to be more regenerative, one is just massive amount of fossil fuel input, hauling all that stuff back and forth. It's just the most efficient nutrient delivery system in the world is a cow walking out there and eating grass and depositing her own fertilizer. So again, another perfect example, we've tried to engineer a biological system, and it's had lots of unintended consequences. So it makes it much more difficult to distribute your nutrients across the landscape. We've got lots of livestock in concentrated areas, and the timing of it as well. We end up putting on a whole bunch at one time because we got to fit it in between getting the crops in and out. So definitely some challenges there.
And part of the reason that the cow is the most efficient nutrient delivery system ever is because she's so inefficient. I think it was Steve Kenyon I heard him talk about one time. If we were to design a cow, if humans were designing a cow, she would be 99 or 100% efficient. But she's more like 20 or 30% efficient, that most of what she consumes is coming out the back end, and she's only using a little bit of it. Well, that's why she works so well as a nutrient delivery system, is because she's not using everything she takes in.
Yep, for sure.
What is the biggest barrier in Iowa? What's the biggest barrier that you see to people adopting these principles? Is it the time invested in integrating livestock, or I know the answer is mindset, right? But what are some of the other
physical or equipment type barriers that you see keeping people from adopting some of these practices?
Yeah, that is a great question, and we get that a lot. So other than mindset, we'll set that one aside. I think one of the huge challenges that we've got is over the decades, again, this didn't happen overnight. We've basically created this whole system, just using Iowa as an example, where all of the infrastructure now is geared towards corn and soybean production. That's what a vast majority of your crop producers are growing. That's what we have a market for. So markets are a huge limiting factor. So that's one of the things we work on a lot is, trying to help people. Not only are you going to grow this other crop, what are you going to do with it? So that's part of the puzzle that we have to help figure out if somebody's interested in diversifying. So markets are a big problem, and then just scale. Farms have gotten so big, and they got to cover so many acres, and they got to do it. We got more and more extreme weather all the time, so their planting windows are getting tighter. Their harvest windows are getting tighter, so they got to get all this work done in a certain amount of time. And again, we're still chasing yield, so we're going to use our full season hybrids here. And we just don't leave enough time in the fall, and they don't have the manpower, they don't have the equipment to get over thousands of acres and get a cover crop in. If you talk to a farmer who hasn't planted cover crops, that's going to be the first thing they're going to say is, when the heck am I going to have time to do this? And with what labor? Because, it's hard to find labor. So that's probably markets, and then just the scale of our operations now, just getting all of this done in a timely manner are the big barriers. And then on the livestock side, obviously we talked about that. We put everything in confinement, tore out a lot of the fences. So there's a lot of work to do there to get that livestock back out in the landscape. We need the fencing and the water infrastructure to make that happen.
I don't know how you fix it. It seems to me like there is a lot of inertia that we have to overcome to get these things done. And I think that there's a lot of incentives, from crop insurance and some of those things that keep people from doing these kinds of things. And so I don't know if you've got thoughts or if you've seen people make that transition successfully, and can give some advice as far as how people would go about making that transition.
Sure. Yeah. And that's another one I didn't mention. I'm glad you brought that up, is the crop insurance issue, because that really distorts markets and really kind of drives what we grow and where we grow it and how people do things. So policy is definitely another part of that. But yeah, as far as making this transition, it's certainly doable. People just need to be prepared for the fact that this is going to take some time. It's not going to be easy, but we're seeing more and more interest from consumers, which is really going to help. Like looking for alternative, they want to buy food locally. Not everybody, but there's more and more people. So there's an opportunity there if you can connect directly with your consumer. And that's not for everybody. Another bottleneck we have here is we found out the hard way during COVID. We don't have enough local meat processing capacity. Most of those small plants have gone by the wayside with our small farms. And so that's another big bottleneck. Okay, if I want to do grass-fed beef, for example, and I want to sell it locally, that's great, but who's going to process it? So that's something that we're going to have to work through, and there has been a fair amount of action on that in the last couple of years, trying to get more of that local processing capacity back so that people can do that. There's farmer groups starting to collaborate together and, think about, okay, can we get a number of growers together that are all going to supply, beef in a local or regional area and have it processed in one place? So there's opportunities like that you can look for. I guess the best thing I can say is talk to someone else who's done it and ask them how they did it and figure out where do you fit in that system? Because not everybody can do everything. So you got to decide, are you going to do, cow calf all the way to finish and sell the meat? Or maybe you should just do stockers, and just let somebody else finish them. Maybe you can plug yourself in there somewhere and add some value without you having to try to figure it all out yourself.
Yeah. And, as I see it, we're really not that far removed from the history that you're describing. Like, and somebody can reach out to me and correct me if I'm wrong. I've found myself saying this a lot recently, but I think it's because it's really important. That, as I understand it, there was a ramp up of the industrial machine or machinery to fight World War II. And once all of that ramped up and was created, World War II comes to an end. Now we need a place to go with all of this production capacity of machinery, and it got turned towards agriculture. And so we're talking less than 100 years since a lot of this really mechanization of agriculture really took off, and where people started to be able to farm more and more and more and more acres. And so we're not that far removed from it. And so, yeah, there's a lot of the markets and a lot of inertia and a lot of the ways the infrastructure is created for corn and soybeans. But I would say that is even more recent than the mechanization of agriculture. And so it's possible to get back to a system that is less, siloed, for lack of a better term, no pun intended, but it's possible to get back to that system. And when we do that, when we get back to integrating livestock in a diverse rotation and, all of these things, living roots and armor on the soil and all of these things, when we get back to those things, then a lot of these problems, as you said, almost fix themselves, but it takes time. So first of all, do you understand that history differently, or are you understanding it at least similar to what I've described here as far as how all of this kind of got to where we're at now?
No, yeah, I think you totally hit the nail on the head there. I mean, that's essentially, like I said, we had all of that excess capacity after World War II, and then they also figured out herbicides around that time, and so it just really changed the whole system. And I have one of this graphs I like to present, and it's just like an exponential decay. And I ask people, what do you think this graph is? And usually nobody knows. Well, it's the number of farms and number of farmers in the U.S. I mean, it just craters after World War II. I mean, we lost 80 to 90% plus of our farmers. It's just a huge amount. And that number is still dropping. It's kind of leveled off a bit now just because we've lost so many people. There's not that many farmers left, but we're starting to see more of a resurgence, on the small farm side of things. But yeah, essentially we just industrialize the entire food production system, on not only at the farm gate, but what happens beyond that too, and how we process it and how we get it on the store shelves. And it's incredibly energy intensive. Another fun statistic I like to throw out is how many calories it actually takes to produce a calorie of food that makes it on somebody's plate. And it's like 13 calories to produce a calorie of food now. And we think our system is efficient. You used to be able to, back when you had horses and muscle power, you could produce like 5 calories of food with a calorie of work. Now it's 1 to 13. Wow. So about 2 of that is at the farm gate. So it's not terrible, but we definitely got some improvement to do there. Just actually producing it on the farm, getting it on a truck. The next 8 is all the processing and packaging and transportation, all that energy we use to actually get that food and wrap it and ship it somewhere and freeze it and all that. And then the last 3 and change is food waste or stuff that spoils or just never makes it onto a plate. So it's actually an incredibly inefficient system when you look at how much energy goes into producing food now. And that's all part of that whole system that developed, in the second half of the 20th century.
One of the lessons I've learned in the course of hosting the Working Cows podcast is to temper my zealotry. And I think you talked about that a little bit, of not just asking people to rip the Band-Aid off and go on every quarter or, on every piece of land they manage and do this year one, and to take some time and to work up to that. And so I'd like to give you an opportunity to just expand on that a little bit before we point towards wrapping up.
Sure. Yeah. We really need to meet people where they're at and take this in baby steps. Now, some people, maybe they go to a soil health academy, for example, and their brain kind of explodes and they just realize all of the stuff they've been doing and the things that are broken, and then they understand why things aren't working, and they go home and they just go all in. I'm thinking of one producer in particular. He just went home, just sold all his tillage equipment and bought a 60-foot drill and just went all in, planting like 3,000 acres of cover crops now. I mean, that stuff's super exciting.
I don't want to be the guy that gives that advice. Like, I was just sitting across the table from somebody who was thinking about making a pretty radical shift in their strategy. And I'm like, experiment, please. Don't go to the neighbors and say, well, he told me if I did this, it would work. I said, please experiment on 20 acres.
Yeah, I would not advocate doing it that way, but some people do it and they make it work. They're dedicated and it has to work, so it will work. So it's kind of a mindset thing. But for most people, I would encourage them to start small. Just whatever you can, 5% of your farm. Whatever you can sleep at night. How much can you, if it turns into a total disaster, how much can you afford? Our job as consultants is to make sure that doesn't happen. Because we've seen this happen on many, many farms all over the country, all over the world now. So we can at least help work through some of those hiccups so they don't have all of these failures and get frustrated and give up. But still, we encourage people to start small, make small changes in just whatever pace they're comfortable with. Once they figure it out on a small scale, then they can expand it to the whole farm or however they want to go about that. So it's different for each producer. It's all comes back to their context and what they're comfortable with.
Very good. You mentioned that there's 2 or 3 more pieces in the series to come out. Could you give a little preview of that?
Sure. So the parts that are coming out get more into the nitty-gritty details on nitrogen management. It's kind of how I tailored that blog. So if people are interested in that, when to apply, how much to apply, what forms to apply, all that sort of thing, that's going to be upcoming in those blog posts that have not come out yet. So hopefully people will check those out.
Sure. Like I said, linked in the show notes page for today, workingcows.net/355. So go there, and the ones that are out now will be up and linked there. And the rest you can continue to tune back in there to the blog and find them at understandingag.com. So, Brian, I appreciate your time today. Anything we missed, anything that you felt like really needed to be said on this topic before I let you go?
No, I think we appreciate the opportunity to be here. We covered a lot of ground today. I know this isn't maybe a typical topic for the Working Cows podcast, but I appreciate the opportunity to be here and talk row crops with you. So yeah, check out the blogs, check out our website. Lots of great information there. I've got other blogs on dealing with compaction and things like that as well. And other consultants have a lot of great information, lots of resources, fact sheets. We are going to be upgrading the website here, hopefully not too far in the future. So keep an eye out for that as well. And also check out the Soil Health Academy website. If you're focused on row crops, we do have a couple schools coming up this summer specifically on row crops. So June 18th through 20th, we're going to have one in Dyersville, Iowa, and then there's one in July. I don't know the exact dates off the top of my head, but that one's going to be in Indiana. So check out the website for those.
Very good. Sounds good. Brian, thanks for your time today.
Yeah, thanks for having me.
Very good stuff there with Brian. Really appreciate his perspective. Really appreciate the idea of applying an engineering fix to a biological problem. That really resonated with me, and appreciate the way he articulated that. Looking forward to next week on the Working Cows podcast. We'll be talking to Elaine Fraze about how do we train the next generation? How do we equip them for success? How do we set them up to succeed? Giving them the experiences and education they need to be able to lead businesses from an early age, relatively speaking. So looking forward to that conversation. Also wanted to let you know that I will be hosting, facilitating, emceeing a webinar open to everyone put on by the South Dakota Grassland Coalition on drought management. The title of the webinar is Drought, Plan Now or Pay Later. And to help get the word out about that, next week we'll have a bonus episode as well with Alejandro Carrillo. And so we'll be talking to him about how he has turned his desert into a grassland, 10 inches of rain on average per year, and it's a thriving ecosystem there. And if he can do it there, then we can do it in a drought here. And so that's basically the idea of the webinar and the idea of this upcoming bonus episode that'll release next week to get the word out about the webinar that's taking place on the evening of April 4th. So there'll be a link in the show notes page for today, workingcows.net/355. Also, keep your eye out for that bonus episode coming up, getting the word out about that. So we'll see you again real soon with another episode of the Working Cows podcast.
We invite you to visit workingcows.net to subscribe to the show via iTunes or Stitcher. You'll also find detailed show notes pages, resources from our guests, and the industry leaders who have influenced them. For more ideas on putting your cows to work for you in a more profitable way, tune in next week.